This video is about how to use the lone divider method when it doesn't quite work out so nicely. So I have Alice, Bob, and Carol are splitting up a cake that they bought for $12 at the bakery. They are each entitled to at least $4 worth of cake because that is what 12 divided by 3 is. And here's a picture of the cake. So Alice will be the divider. So it is her job to cut the cake into 3 equal pieces that she feels are each worth $4. Remember, as the divider, she's not going to have any control over what piece she gets, so she needs to make sure that each piece is worth $4. And so that I can tell them apart, I'm going to give the pieces names so that you can see which one is slice 1, which one is slice 2, and which one is slice 3. This will make it easier to talk about them later. So Bob evaluates the pieces. He decides that slice 1 is worth $6, slice 2 is worth $3.50, and slice 3 is worth $2.50. So the only piece that Bob will accept is slice number 1 because that is the only one that is worth more than $4. Now Carol comes along and she evaluates the pieces. She thinks that slice 1 is worth $5, slice 2 is worth $3.50, and slice 3 is also worth $3.50. So Carol will also only accept slice number 1. So because Alice is the divider, she must find all 3 slices acceptable. Bob will only accept slice 1, and Carol will only accept slice 1 as well. So this presents a problem because we cannot give each player an acceptable slice. So I am putting all of the values of all of the players on the screen at once so that I have a summary of what's going on here. These are just the values that I said before. So we will give Alice a piece that Bob and Carol don't want. This could be either slice 1 or slice 2. So because Bob values slice 3 the least, I'm going to give that to Alice. So Alice takes her piece of cake and she leaves. So that's gone. So I'm going to indicate that that's gone by scribbling it out. So here's the information for our remaining 2 players. I removed slice 3 since it's gone, no one cares what it was worth before. So we're going to make Bob be the new divider. So since Bob values slice number 1 more, what he's going to do is try and move some of slice number 1's value onto slice number 2, because Bob will not have a choice as to which of these pieces he gets, so he needs to make them both even. So here's how we figure out how Bob is going to do that. According to Bob, slice 1 and slice 2 together now have a total value of $9.50, because that's $6 plus $3.50. Bob's fair share of this is $4.75. I got that because there are 2 players, Bob and Carol. Bob is entitled to half of the remaining cake, and half of $9.50 is $4.75. So what Bob needs to do is make both pieces worth $4.75. So how's he going to do that? Like this. He values slice 1 at $6 and slice 2 at $3.50. Slice 2 is not worth enough, so he needs to add $1.25's worth of cake added onto it, because $3.50 plus $1.25 is $4.75. So we need to remove $1.25's worth of cake from slice number 1 and give it to slice number 2. So that means that slice number 1 will also be worth $4.75 because that's what $6 minus $1.25 is. So what does this look like? Well, I'm not sure because I'm not Bob, but for sake of argument, let's say that the picture is going to look like this. So I've moved the top line to make slice 1 and slice 2 different sizes. And since they are different from the original slice 1 and slice 2, I have given them both little subscript 2's. So according to Bob, slice number 1 version 2 and slice number 2 version 2 each have a value of $4.75. So he will be happy with either piece. But now Carol gets to look at the 2 of them, evaluate them, and take the piece that she wants. So how can we figure out how Carol values these slices? Well, very carefully. This gets a little bit tricky, so take it slow and pay attention. Slice 1 was worth $6, but then Bob removed $1.25 worth of cake from slice number 1. So we have to ask this question. What fraction of the slice of cake did Bob remove? We can figure this out by just setting up a fraction here. We're going to take $1.25 because that's what he removed, divided by 6 because that's how much it was originally worth. And if you divide this out, you get 0.208 and other numbers. So this is about 21%. Remember, to convert a decimal to a percent, we just multiply it by 100. So Carol has no idea how Bob values things, but she can see that he removed about 21% from slice 1 and gave that to slice number 2. So Carol thought slice number 1 was worth $5 and slice number 2 was worth $3.50. She observed that Bob removed 21% from slice 1 and gave it to slice 2. So 21% of $5 is $1.05. You figure this out by just taking 0.21 times 5. So according to Carol, slice number 1 is now worth $3.95. It used to be worth $5, but he removed $1.05 from it, so it's worth $3.95 now. Slice number 2, which used to be worth $3.50, has gotten $1.05 added onto it, so now she thinks it's worth $4.55. So she will take the slice that is valued higher. She will pick slice number 2, leaving Bob with slice number 1. So Alice, well, she thought that slice number 1 and slice number 2 were both $4. Because she's the divider, that's her job. So remember, Bob cut 21% from slice number 1 and gave it to slice number 2. 21% of $4 is 84 cents. So Alice thinks that the new slice 1 is only worth $3.16 because we took 84 cents away, and slice 2 is now worth $4.84. So since Carol took slice number 2, Alice might envy her, but Alice cannot deny that Alice got $4 worth of cake, so she can't say it's not fair. So the final settlement here, Alice is going to get the original slice 3, Carol is going to get the new slice number 2, and Bob is going to get the new slice number 1. So now everyone has gotten a piece of cake that they find acceptable.